Hello and welcome to another video by Easy Makes It Easy. In this particular video, I'm going to be focusing on the latest model from OpenAI that just dropped. It is called GPT-OSS. Now there are two versions of this model. The 20b version is the 21 billion parameter version, and the 120b version is the 117 billion parameter version. Now, unlike some of the other open source models, this one has 4-bit quantization, and that makes it able to fit in a smaller GPU memory so that you can leverage it on devices without having to spend too much money on them to get the ones that have a lot of VRAM. So while this tweet dropped, about 20 minutes later, I got this email from Hugging Face showing that this model has been published on Hugging Face around 12:19 p.m., like about 30 minutes after Sam Altman dropped this tweet. So if you head out to Hugging Face, you should be able to see the OpenAI models, the 20b and the 120b. There's also an announcement that I'm going to put the link in the description. Microsoft also published an announcement that these models are available in azure-foundry-local. So if that's what you are using, you can get access to it there. On Ollama, you can access the 20b and the 120b versions of it. Right now, a lot of people are downloading it. About 112,000 people are currently downloading it. On AI Foundry, you should be able to grab 3 versions of this. So I see the 20b version and the 120b version, as well as the 20b CUDA GPU version. So all these are versions of this open source model available in the AI Foundry model catalog. So there are so many ways you can run this. So if you want to do it in the cloud, you can leverage Microsoft Azure and access the 20b and the 120b version. If you want to deploy it self-managed on Kubernetes, you can use Llama CPP, Ollama, or VLLM, and you can run it on Kubernetes using the Hugging Face models that are available, or the model from Ollama. If you want to do it locally, you can use the Foundry Local from Microsoft. So the announcement is published here, or you can use Ollama and then run it either via Docker or via the CLI. So I have my environment here, and I have a sample code that you can follow along. We have 2 versions of this. So the first version is going to demonstrate the structured output functionality, where we have a Pydantic object that has 2 fields, the city and the country in which the Olympic events took place. So I will show you first the reasoning version in the CLI to show you how it is answering the questions without using structured output. And then in the code version, I will show you how to use structured output to get very specific fields and values in your responses. In the second one, we have another structured output slightly modified to be a list of results, where it contains the city, the country, and the year in which the Olympic events was held. So that's what I want to demonstrate in this one. In a separate video, if you subscribe to the channel, you will get it when the video is done. I'm going to show how to use tools with the Pydantic framework to invoke this language model, and then use structured output to get the response, while also using the tool to supplement the memory of the model to get answers and to take actions and do things like that. So that's what we're going to be doing in the next video. But for this one, it's going to be a very brief one to demonstrate how you can specify instructions and use structured output to get the result set back. So let's get started with the CLI. The link to this repo will be in the code, in the description, for you to access and follow along with me as I'm doing this. So if we head over to the code, we have this file here that contains the location of where Ollama is running. I am specifying the model settings and the specific model that I'm going to be using, which is available in Ollama. So if you come over to the CLI and do Ollama list, you should be able to see the models. So how do you get this? If you do Ollama pool and you specify the specific model version that you want, it should be able to pull it if you specify it from this name. So GPT-OSS, and then the tag is 20b or 120b, and that should grab it for your local environment. So let's get started by using the CLI to show you how it is reasoning and how it is thinking. To invoke it in the CLI, we do ollama run, and then ollama run, and then we do GPT-OSS, specifying the specific version. Now, because I am using this to record, it might be a little bit slow, so please be patient. I want to show you everything in real time without fast forwarding anything, so that you can get the real experience. If you're using a different environment, maybe running it locally on a different machine, and then you're trying to access it, that might be a little bit faster. So now the model is ready. So what city was the Olympic held in the year 2016? Let's find out. So I'm going to ask the same question in the Python code so that you can see the difference between the unstructured and the structured output. This model, unlike some of the other ones like DeepSeek, allows you to do structured outputs. So certain reasoning models cannot support structured outputs as well as tool calling, but this one supports both of them. So we're going to show you how it is doing it in here. So while this is waiting, so now it is thinking. It is saying that we need to think the 2016 Olympics were held in Brazil, in Rio de Janeiro. Now it's going to try to provide a concise answer, and it is done with the reasoning. So it is giving me the answer that the Olympics for that year was held in Rio de Janeiro, Brazil, and it is done. So that is for that CLI version. Now, how do we do this using the code? So in the first example here, we are asking it what location was it held in 2012. Now we know that was done in London 2012. But as you can see, the structured output is able to use this. This object here contains two fields, the city and the country, and we are able to get a structured response back from the language model containing those two string fields, and it also shows us how many tokens were used in that response. Now, in my second example, I am not just receiving an object, I am getting a list of objects that contains the city, the country, and the year in which the Olympics were held. And in that example, you can see here that it is listing the 3 years. In 2008, it was in Beijing, China. In 2012, it was in London, in the UK. And then in 2016, it was in Rio de Janeiro, in Brazil. So with this language model, we're able to do tool calling, we're able to do structured output, and we can specify instructions for the model to use as well. So if you follow along with these examples, you would see how this is done using the PydanticAI framework. In my next video, I want to do tool calling, where I will show you how we can retrieve the city, the country, the year. We can also add a special fictitious data set, which is the special gift that the Olympics athletes were receiving for that year. So you will see how this LLM would use the tool calling capability to retrieve this fictitious data set and append it to the result and still give us structured outputs in our responses. So I will do this using the PydanticAI framework, possibly using LangChain as well as the OpenAI SDK to demonstrate this tool calling and structured output capability. So that's what I wanted to show in this particular video. If you like content like this, my channel focuses on how to build AI agents in production, and I felt that instead of just running through the benchmarks and all the different flashy talking points from OpenAI, I just wanted to show you how you can use this language model using the ollama strategy. And if you want to do it in production using VLLM or any other framework for model inferencing, you can do that with Kubernetes, and you should be able to deploy it. If you'd like me to show you how to do that, let me know as well. If you're on Microsoft Azure, you can use the AI Foundry, and you can access the 20b and the 120b version, as well as the 20b CUDA GPU version of this language model in that environment. Hugging Face has the two of them published, so you can download it from there and then run it in your inferencing environment. But for me, I was using the ollama version, and I was doing it locally in the CLI as well as running it in the code, in Python code. So that's everything for this particular video. I am an AI architect that focuses on how to build AI agents in production, specifically on Microsoft Azure. That's my primary cloud environment. And if you like content like this, please subscribe to the channel. Share this video with someone you think will be benefiting from this particular content. And I would publish another one very soon focusing on tool calling. So subscribe if you would like to get notified when that one drops. So that's all I have for you today. I thank you for stopping by, and I will see you in the next video.